Welcome to the deep dive. We're here to cut through the noise and give you the knowledge that, well, actually matters. And if you're deep in your ATPL theory prep right now, you've probably met the big beast, the CIP 697 workbook. Specifically, those medium-range jet transport charts, the MRJT stuff. It can be pretty daunting.
Oh, absolutely. Yeah, for anyone staring at those, really dense tables, those planning graphs, this is for you. Think of this as your shortcut. Our mission today, it's super focused. We are pulling out the essential numbers, those hidden corrections, and the, let's say, 4 main calculation types the examiners love to throw at you. We want to basically turn that dense information into something, targeted, effective knowledge you can use straight away in the exam.
Okay, right. So let's set the stage first. What is this MRJT aircraft we're talking about? It's theoretical, right? A simplified model just for the exam.
Exactly. It's a twin turbojet, retractable gear. Think something like a 737 or an A320, roughly that size, but really geared towards that medium range profile.
Gotcha. So before we even think about how far it can go, we need its basic DNA, its limits.
Precisely. And that DNA, it starts with the hard limits, the structural boundaries. Every single calculation, the fuel, the payload, it all hinges on these numbers. So section 1, the basics, the constants you just have to know.
Right. These structural limits, we need to kind of burn these into our brains, yeah.
That's right.
They define the aircraft's operating envelope. They're the absolute starting point for figuring out what you can carry safely.
Couldn't agree more. Let's run through the big 4 structural mass limits. Starting right there on the ramp, you've got your maximum ramp mass, the NRM. That's the absolute max weight allowed when you're parked or taxiing. For this MRJT, it's 63,060 kilograms.
Okay, 63,060. And straight away, you've got to compare that to the next one, the maximum takeoff mass, or MTOM.
Which is 62,800 kilograms. That's the limit the second the brakes are released for takeoff.
Hang on, there's a difference there. 63,060 on the ramp, 62,800 for takeoff. That's 260 kilos. Why that specific difference? That 260 kilogram gap, it must be important, right?
Oh, it's fundamental. It's your mandatory fuel allowance just for getting from the gate to the runway. That 260 kilos covers your engine start, any pushback, maybe running the APU while passengers are boarding, and the taxi out itself. It basically guarantees that when you line up and push those thrust levers forward, you're at or below the certified MTOM.
Ah, okay, that makes total sense. So if you get stuck in a massive queue for departure, like say 40 minutes, you could easily burn through that 260 kilogram, couldn't you? And then you'd be overweight for takeoff.
Precisely. And you might have to go back, get more fuel, recalculate everything. It's a real operational headache. And the examiners, they love testing if you know the actual burn rates for that ground fuel. So if a question says, 10 minutes taxi time, you need to remember that taxi fuel is roughly 11 kilos a minute. Or if you're running the APU on the ground, that's about 115 kilos per hour. Little details, but they matter hugely in fuel planning questions.
Okay, got it. So those are the ground limits. What about once you're airborne or coming back down?
Right, then you're looking at the maximum landing mass, the MLM. That's set at 54,900 kilograms. Usually, this is about the stress on the gear and the airframe during touchdown. Land heavier, and you're looking at mandatory inspections. So the plan always has to ensure you're below this weight when you arrive, even if that means maybe orbiting to burn off a bit of extra fuel.
And the last big structural one, maybe the most critical for figuring out how much payload you can actually take, the maximum zero fuel mass, MZFM.
Yeah, MZFM. 51,300 kilos. This one's a bit different. It's the maximum weight of the aircraft before you add any usable fuel. Why? Well, it's all about protecting the wing structure. If you load too much weight into the fuselage passengers, cargo, the plane itself, the wings, which are holding all the fuel out wide, could bend too much. It prevents excessive stress at the wing root.
So the MZFM is what really limits your payload, your traffic load, as it's called. How do we figure out that maximum traffic load number?
Well, first, you need the aircraft's empty weight plus crew and essentials, which is the dry operating mass or DOM. For this MRJT, the average DOM is given as 34,270 kilograms. That includes crew, catering, water.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best